Determine the sum of squared deviations for the scores that follow. So my scores are 5, 2, 4, and 5. Either the answer will be 6, or 16, or 70, or we first need to know if it's a population or a sample. Now we can rule out D. The reason for that is that regardless of whether or not this is a sample or a population, and regardless of whether or not I use the definitional formula or the computational formula, I have everything that I need to be able to calculate this out. So, for example, the sample definitional formula looks like this. It's sum of squares equals to the sum of each x minus the sample mean squared. Now, I know what each x is. I could find, if I consider this to be a sample, I could find the sample mean. I could do that just by adding these up and dividing by 4. If I were to consider it to be a sample and I wanted to do the computational formula, I would need to have the sum of x squared, which you can find anytime you have all of your raw data. I would need the sum of x. Of course, I could find that too, and divide by the sample size. If it was a population and I'm working with the definitional formula, in that case, I'm going to be looking at each score minus the population mean squared, and the computational, sorry, I think I said computational last time, so this is my definitional for the population. If I'm dealing with the computational, then it's going to be the sum of x squared, which I can find whenever I have raw data, minus the sum of x, which again I can find over the population size. So I can work things out no matter what, and I'm going to get the same result no matter which one of these I choose, whether it's a sample or a population. So makes no difference. Let's just grab this one here. It means that I need to know the sum of x. So 5 plus 2 is 7, plus 4 makes 11, plus another 5 is 16. I know that n, or I guess I'm considering this to be a population for this calculation, so I'll make it a big N. Big N is 4. I need my x squared value, so 25, 2 squared is 4, 4 squared is 16, 5 squared is 25. Let's add these up, and that will give me my sum of x squared. 25 and 25, that makes 50, and then these two make 20. 50 and 20 is 70. So my sum of squares requires that I know the sum of x squared, which is 70, minus, in brackets, the 16 squared over 4. So that's 70 minus 16 squared is 256. Divided by 4 is how much? 256 divided by 4 is 64, so it's 70 minus 64. This gives me 6. So my sum of squares is 6, and so the answer is A.